Hello students, today we will do this experiment which is known as specific resistance by ammeter voltmeter method. The circuit diagram is as shown in the figure. Now if you look at the portion which is this and this, you will see an instrument marked V and something known as R. This R is actually not a resistor or a resistance. It is the wire whose specific resistance has to be found out. This V is a voltmeter. This MA means it's a milliammeter. This B is a power supply. This K is a plug key. This RH is a rheostat. Now before we start with the experiment, since this is the first experiment, let me show you a few more details as well. This is an ammeter. You can see here A is written here, ammeter, fine. Second one, this is MA. MA means milliammeter, fine. This one is a voltmeter and this one is a millivoltmeter and this one is a galvanometer. Now whenever you start doing your experiment, if you do not know what the apparatus is, always look within this dial. This V or MV or A or MA will surely be written inside this dial. So that will help you to locate what is the meaning of what does the apparatus mean, what is that apparatus for. This is a single way plug key. This is a two-way plug key. In a two-way plug key, this particular terminal has to be connected. It's a common terminal. This is a four-way plug key. This one is a rheostat. I will compare the rheostat with the circuit diagram which is shown. Now in this circuit diagram, this one stands for the rheostat. This is one end, this is the second end, and this arrow mark is the variable terminal. Let me just compare this entire thing with the actual rheostat. So in a rheostat, if you see, there are two fixed terminals, one terminal here, one terminal over here, and this happens to be your variable terminal. So this variable terminal here is equal to this connection here, this arrow mark here. This lower terminal, there are two in numbers. You can use either of these two terminals. You have got one terminal over here, one terminal over there. This is left blank, but that doesn't mean the circuit is incomplete. It only means that you have taken care of one of the lower terminal and the compulsorily to be fixed variable terminal. You can use either this or that, or you can use either this or the immediate one. Depends. Only thing is, while moving this particular knob over the rheostat, you'll have to adjust your readings accordingly. Either you move it away from you or you move it towards you. Now when we get back to this circuit diagram, let me just show you how the connections are made. Now please remember, any circuit diagram, however complicated may it be, can always be broken down by thinking that these lines are actually the wires which are connected to each other. Now you know, here voltmeter has got two terminals, a millivoltmeter has two terminals, an ammeter has two terminals, a milliammeter has two terminals, a galvanometer also has two terminals. So now here this voltmeter has got two terminals. How the connection is made, this is a wire, fine. Anyway, the wire will be a wire itself. So straight away take the wire's one end and plug it into the negative of the voltmeter, and take the other end of the wire, the resistor, and plug it into the positive of the voltmeter. Now, while you are connecting, please remember that you don't have to use your might to tighten the screws. Now if I can show you, there is a small slot. Can you see that small little slot there, hole there? That is where the wire has to be inserted, and after you've inserted it, just gently tighten it up. You don't have to show your gym power on these poor knobs. Okay, so this is complete. After you have connected these two, now this wire means it's a common wire. Common wire means from here itself, from where you have connected the wire to the voltmeter positive, from there itself you can take it to milliammeter negative. Take a wire from here, milliammeter negative, and put that into the milliammeter to voltmeter positive. From the voltmeter negative, take another wire, and that will go to your variable terminal of the rheostat. Remember, this is a common connection between R and V. It's a common connection, okay? And here normally, now it will get to this milliammeter. So milliammeter positive, take one more wire and connect it to the battery positive. See, here you should not get confused. Why you should not get confused? That's because normally we always connect negative to the positive, correct? But here we are connecting positive to positive. That is because our milliammeter is always connected with its positive terminal to the battery's positive terminal, because a milliammeter is an instrument which measures the amount of current which is flowing in the circuit. If you connect negative, there will be no flow of current. So you always have to connect positive to positive of the battery. Fine. But I need to mention here, this is a galvanometer which I have already spoken to you earlier. This is an instrument which is not used to measure the current. It is used only to indicate whether there is a presence or an absence of the current. It is like your own body. See, suppose whenever you accidentally touch an open wire, do you not get a shock? So now, do you leave that thing or do you hold on to the wire? You naturally will throw it off, correct? That's because you know if you hold it on, it will hurt you. So naturally, this galvanometer also will not measure the current, it will only indicate. Let's go on to the connections now. As you can see, I have inserted this wire into that small slot over here into the voltmeter, and I have also inserted the experimental wire whose specific resistance is to be found out into that slot as well, because both have to be connected at the same spot, and I'll be tightening this. Don't tighten it too much, just enough for it to stay at place. So I have already done the entire connection, and if you compare this circuit diagram to the connections what I have shown, now here you see the common terminal is go to variable terminal of the rheostat. Here is the common terminal, and that is going to the variable terminal of the rheostat. From the lower end to the plug key, from the other end of the plug key to the negative of the battery, to the positive, from the positive it goes to positive of milliammeter, and from the negative it goes to the voltmeter. Now how do you start the experiment? You can put it on. As you can see, I have already started the battery eliminator, and I have kept it at around 6 volts. You can even do it at 8 volts also, but depending on what is the range of the milliammeter, you can decide how much is the value of the voltage to be kept. Okay, now you insert the plug key. Suddenly you see that there is always some current there and there is some voltage over there. Now remember, one very important thing about Ohm's law is how do you remember that values. Now normally what we do, we say V is equal to IR is the Ohm's law. Now that would mean, and if you compare that to a line equation, Y is equal to mx plus c, what is dependent on what? Y is equal to mx plus c. In that equation, y is dependent on x. So normally when we look at any equation, whatever is there on the left hand side of the equation is dependent directly on the right hand side, and sometimes inversely or in inverse proportion as well. Fine. So now when you say V is equal to IR, we are somehow forced to say that V is dependent on I, which is not the correct way of talking about Ohm's law. So what you should be doing is, you remember the Ohm's law as I is equal to V upon R, which will then prompt you to say that I is dependent on V. So we should now be bothered more about changing the value of V rather than noting down the value of ammeter readings first. So when we start the experiment, we will change the values of voltages by whatever amount. Now if you see this carefully, between 0 and 1 there are 10 divisions on the voltmeter. So each division will be 0.1 volts. So you got 0, 0.1, 0.2 up to 1, 1.1, 1.2, whatever. We'll just take one reading and see what is the value on the voltmeter. Fine. Have a look at it, this one now. Here you can see the needle is on, I am adjusting the rheostat. It's 2 divisions above 1, so that will be equal to 1.2 volts. Okay, now let us look at the milliamp reading. It is exactly on 300. So reading is 300 milliamps. So for 1.2 volts, your reading of current is 300 milliamps. Let us take one more reading and see how the thing changes. Now I have kept it at 1 volt here. Fine. So what is the value over there? It is 2 divisions less than 300. If you see for the milliammeter, between the numbers 200 and 300, there are again 10 divisions. So each division will be equal to 10 milliamps. So now because it is on the 8th number, your value is 280 milliamps. So for 1 volt, it is 280 milliamps. Let us also now try to take a few more readings. So let us now bring the values at, say, now this is 1.4 volts, and what is your reading in the milliamps? It is almost between that 340 and 350 limit. So shall we take it as 345? So for 1.4 volts, it is 340. Take a few more. Now let me take it as, this is 1.6 volts, and there your needle has come between the last but one and the last digits, or between the 7th and the 8th digit, or 8th and the 9th digit. So you can take it as 385 approximately. So for 1.6 volts, it is 385 milliamp. So now let me go into one more reading. This is approximately 1.8 volts, and that is approximately 430 milliamps. So for 1.8 it is 430. If you want, you can go down to some other reading also. Say for example, say let us get it to at 0.8 volts. This is 0.8 volts, and that is approximately 225 milliamps. For 0.8 volts, it is 225 milliamps. So now let's take one more reading, which is 0.8 volts here, and this would be approximately
190 milliamps. So we have got 0.8 ohms and approximately 190 milliamps. We'll take a few more readings if possible, because if there is an error later on, then we can neglect a few readings here and there. So let us now straight away go to about say this one is approximately 2.3 volts. Will not test going beyond the scale. This is approximately 2 volts, and here we are getting a reading which is approximately 485 milliamps. So for 2 volts approx, we are getting 485 milliamps. Let's quickly take one last reading. We have put this at 2.15 volts, and this is exactly 500 milliamps. So for 2.15 volts, we are getting 500 milliamps. I'll just show you one little trick here. This is the way you either move the rheostat away from you, because of which the voltage will come down, and when you move towards you, the voltage will come up. This is exactly how you take, but keep in mind that this dial, this needle should not go beyond this dial. Okay, if you do it too much, it goes beyond, so that won't be that will harm the milliammeter. So this is exactly what you need to do. So this is exactly the setup. This is exactly how the connections have been made. Now what you do in the last is you have to remove this fellow, put off that fellow, and this is the experimental wire whose specific resistance is to be found out. This one is the experimental wire whose specific resistance is to be found out. We use the screw gauge. We use the screw gauge to measure the radius of this wire. We'll use the screw gauge to measure the radius of the wire. That use of screw gauge, you can refer to my other videos. By using the screw gauge, we get the radius of this wire as 0.43 mm. Sorry, we get the diameter as 0.43 mm. We need to convert that into the radius. So 0.43 upon 2. So that calculation I will show you a little later. And we will also measure the length of this wire, the experimental wire, by making use of a meter scale, and this is approximately equal to 98 centimeters. We can add another 2 and make it to 100 centimeters, which is equal to 1 meter. That will be easier for us to do the calculations. So okay, now initially when we had started the experiment, we had taken a few readings. When you people were busy checking your other messages on your Facebook or WhatsApp or other social apps, I was a little busy in taking a few more readings. So now, just a little joke, we just have a look at these readings what I have taken. I use the voltages from 0.8 volts to 2.15 volts, 0.85 volts to 2.15 volts, and corresponding to the voltage reading, I have taken the current reading as well. Now if you look at the first one here, which is current MA, that means the current is in milliamps. So whatever reading I have got here, I have multiplied that by 10 raised to minus 3, because 1 milliamp is equal to 10 raised to minus 3 amps. Okay, now we will use this formula, which is the Ohm's law, R is equal to V upon I. So we'll take the values from column number 1 here, which is V, that is 0.8 upon 2.25 into 10 raised to minus 3. That will give me a value equal to 3.57 ohms. Similarly, we'll take 1.2 volts, divide by 300 into 10 raised to minus 3, and we get 4 ohms. We take 1.4, divide by 345 10 raised to minus 3, we get 4.05 ohms. 1.6 upon 385 10 raised to minus 3, we get 4.15 ohms. Similarly, by doing all these calculations, we end up getting these values in the last column. Now you see the values 1, 2, 3, 4, 5, 6. All these 6 values are in that 4 ohms, a little above range. But only that fellow 3.57 is a little out of range. So we can safely neglect that and we take only the bottom 6 readings. So when we add these 6 readings, we end up getting a value of 24.72. You can do the addition yourself. You can add this number 4.05 plus 4.15 plus 4.10 plus 4.12 plus 4.30. And since we have taken only these 6 readings, you add it up and divide by 6 and you end up getting a value of 4.103 ohms. So this one is the resistance of the given wire, the specific resistance of which you are going to find out. Now believe me, this same setup can also be used as a second experiment, which can also be told as verification of Ohm's law. Rather, that verification of Ohm's law will be your first part, which you can use anywhere you want, and this is the second part. Just add up the calculation of the specific resistance. So whenever you are doing an experiment on verification of Ohm's law, you follow the same circuit diagram, you follow the same method, you follow the same number of columns, but there what you have to do is these values what you get should be the same, and in this case of voltage and current, you can even write I over there. Voltage and current, when you are doing experiment on verification of Ohm's law, you have to draw a graph of V versus I. That means you have to take a graph of V on the y-axis and your current I on the x-axis. So then when you draw the graph, you will get various points, almost a straight line. Now what you can do is you can start from the 0 line and mark a line which covers equal number of points on either side of the line. I will just show that to you quickly how to do that approximately. So you can approximately draw a graph, something like that, but on during your classwork you can refer to a graph and you can use the graph paper, graph sheet, and you can draw this following diagram. Here on the y-axis you take the value of the voltages, and on the x-axis you take the value of the current, okay, and you take the value of the slope somewhere. See, I've drawn this line here. There are 2 points on this side, there are 2 points on that side, so it's kind of an average line. Anywhere you can take the slope of this, anywhere you can take the slope. So this is your value of V, that will be your value of I. So this V upon I will give you the value of the current R. So this should also approximately work out to about 4 ohms, that you can check if you are doing this experiment of verification of Ohm's law. Let us now get back to this experiment. Now we'll do the calculations and we'll see what the results are. We have found the mean to be equal to 4.103 ohms. Fine. We had found the radius by help of a screw gauge is equal to 0.43 mm. The diameter we had found at 0.43 mm. That divided by 2 will give you the radius, which comes to 0.215 mm. Always remember to convert that into meters. So you multiply 2.215 10 power minus 3, that converts to meters. Fine. So from this what will you get? The area A is equal to pi r square, which is area of the cross section of the wire. So you can do all that calculation and you end up getting 0.1451 into 10 power 6 square meters. That is equation number 1.
we had said the length was equal to 98 centimeters. We had another approximate 2 centimeters, that becomes 100 centimeters. That's equal to 1 meter. Equation number 2 we say. And mean R we have taken from here, which is 4.103. So that is equation number 3. Now what is the formula to be used? Rho is equal to AR upon L, where rho is the specific resistance of the material of the wire. This A is the area of cross section. This R is the resistance that we have found out. This L is the length of the wire. So now what you can do is equation number 1 into equation number 3, this equation number 3 upon equation number 2 is what you will have to put in these values there. Fine. So what do we get? Shall I wait for a minute or so? You can continue. Just do this calculation and you should end up getting the value. You should end up getting the value 5.953 into 10 raised to minus 7 ohm meters. This will be the specific resistance of the material of the wire. Now sometimes what all questions can be asked on this particular experiment? Something like a viva or a short answer type questions. So what can be the oral type of questions? Number 1, can you define specific resistance? So what should your definition? Next question would be, do you know the units of specific resistance? What can the other question be? By looking at the chart, can you tell me what is the material of the wire? Now in that case, what should you be doing? Suppose you are given a chart which consists of various values of specific resistance of various materials. Now with the graph, what you can do is you can check from where you get this much 10 power minus 7 ohm meters, and you can locate that particular material and say, oh, this is the material of the wire. Now sometimes this is a very simple experiment, but such a beautiful experiment, this one, that it serves you 3 purposes. 1, it helps you to verify Ohm's law. 2nd, it helps you to find the specific resistance. 3rd, it also helps you to tell which is the material of the wire. What is the material of the wire? And how do you do that? Finally, you come at this result, 5.953 10 power minus 7 ohm meters. With this result, you check from the tables. You will be given a table. Check where approximately do you get this value, 10 power minus 7 or 5, whatever it is. Corresponding to that, there will be name of the material written, the metal written. You can say, this wire is made up of this particular metal. Fine. Now, there could be lots of errors in the experiment, because of which you may not be getting the exact value, but approximately you can say this is the material. Fine.
Thank you students, and I hope that you do well in your examinations. Please, if you have liked this video, do share it with your friends, and please do not forget to subscribe to this channel so that this channel can grow at least a little bit. Thank you my dear students. Have a great day ahead and a great examination ahead.